In the previous example in section 8.7, we talked about our definitions for terms and coefficients. So what we're going to continue talking about in this case are like terms. Right? So like terms are terms with the same variables raised to the same exponents. Right? So we have the same variables raised to the same exponents. Right? So underneath here I have a couple of little notes. Right? Our variables do not need to have the same coefficients. Right? So in order to be like terms, we're not worried about that coefficient part out front. We're worried about the same variable and the same exponent. And there's also a little note here. The variables do not need to be in the same order. This has to do with our commutative property of multiplication, which we've mentioned a couple of times. The order doesn't matter. We'll also see a little bit more with our commutative property of multiplication in the next section. Right, so AB and BA are actually going to be like terms. Right, so our variables do not necessarily need to be in the same order, but we need to have the same variables raised to the same exponents. Right? When we are dealing with like terms, we call it combining like terms. So to combine like terms, right, we're going to add the numerical coefficients and multiply the result by the common variable factors. So basically when we're when we're combining like terms, we're going to add or subtract based on our signs, right? Because sometimes addition and subtraction, depending on our sign, our instructions may say one thing, but we'll do the other based on the signs of our numbers. So we're going to add or subtract our numerical coefficients and then multiply the result by the common variable factors. So what we get from our numerical coefficients is going to become our new coefficient that's out front, that's being multiplied by whatever we had. At no point in time as we're going through these should our exponents change. So our variables should not change and our exponent shouldn't change. Okay. All right, so for our next example, we are going to simplify. So combine like terms if possible. Right, so 7x plus 6x. Right, these are like terms. They have the same variable x. They have the same exponent. They both have invisible ones. 7x plus 6x is going to give us 13x. Right, for B, 2h plus 3h plus 6h. We have more than two terms, but they are all like terms. They all have the same variable, which is h. They all have the same exponent, which is 1. So we're just going to add up our numerical coefficients out front. 2 plus 3 is 5, plus 6 gives us 11. 11 becomes our new coefficient that's being multiplied by that h. All right, for C, negative 2 plus 9. Right, we don't have any variables to worry about. These are constant terms. Different signs, so we subtract. Our larger number is positive, so we get a positive 7 for a result. All right, for D, negative 8a squared plus 4a squared. Both of these are like terms. They're both a squared, so same variable, same exponent. We look at our coefficients. They are different signs, so we subtract. 8 minus 4 gives us 4. Our larger number is negative, so we want a negative 4 for our coefficient, and our variable part is going to remain a squared. Right, for D, 4p plus p. Right, well, looking at these, they are both like terms. They both have the letter p, variable p. They both have an exponent of 1. Right, we want to add these. Remember, in front of this other p, there is an invisible 1 as a coefficient. So if you want to write an invisible 1 in here, if that's beneficial to you, definitely feel free to do so. But 4p plus 1p is going to give us 5p. All right, looking at E, 9x cubed plus 9x squared. Notice that these two terms here, right, are not like terms, right? We cannot combine unlike terms. So in this case, since we cannot combine our unlike terms, Right? We can't simplify this expression anymore. It's just going to stay 9x cubed plus 9x squared. Right? So we have the same variable, but they have different exponents. Right? So we can't combine them. They have to stay separate. All right, now when we get to these bottom two here, right, for f and g, right, what we are looking at, we have different pieces. We have more than just 2 or 3 terms here. And we have some pairs of like terms. So we're going to group any like terms that we have together. So looking at our terms, we have a 5x and a negative 2x that are like terms. Remember that coefficient is negative 2. That negative sign goes with that 2. So if we combine those two like terms, they're different signs, so we subtract. We get 3. Our larger number is positive, so it stays positive 3x. Right, then if we look at our other two terms are just numbers. Remember, we call these constants. Right? So negative 2 minus 8. Right? We have a negative 2 and a minus 8, or negative 2 and negative 8, however we want to think about it. They have the same sign, so we're going to add them. Right? So that's going to give us 10. And they're both negative, so the 10 stays negative. Right? We have negative $2 in our bank account, and then we go spend 8. Well, now we're at negative 10. We can't combine anymore because our 3x and our negative 10 are now unlike terms. Right? So we cannot combine those last two. We've simplified, we've made it look nicer, we combined our like terms that were possible, and now we hit a point where we're going to stop. Right, g is going to be similar. We have a 2w squared and a 7w squared. Everything's positive. We add our coefficients. 2 plus 7 is going to give us a 9w squared. Right? And then our other terms are also like terms. We have a plus 3w and a minus 5w. A positive 3 and a negative 5 is going to give us a negative 2. Different signs, so we subtract. Our larger number is negative, so we have a negative 2, and then we keep a w for that term. So when we're combining like terms, again, we need to have the same variables raised to the same exponent. Right? We can only combine our coefficients when that's the case. Right? At no point are we changing exponents or doing anything to the variable pieces. We're just matching up and using coefficients of our like terms.